Hi all, welcome to my YouTube channel Know About Embedded Systems. So in today's video, we will discuss how to set and clear the bits in C programming. How to set and clear the bits in the C programming. So this topic is also one of the interviewer favorite topic. In most of the interviews, the interviewer will ask the question to the students, how to set the bits and how to clear the bits. So before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on C programming and embedded systems. Let us start the video. So how to set and clear. So if you want to set and clear the bits, first of all, you should know the bitwise operators which are available in our C programming. So here I don't discuss all those bitwise operators which are available. Just I'll tell you the brief information about these bitwise operators. So first of all, if you want to set any bits, I'll be using the OR operator. If you want to set the bits, I'll be using bitwise OR operator. If you want to clear the bits, I'll be using. So if you want to clear the bits, I'll be using bitwise AND operator. And if you want to toggle the bits, or if you want to flip the bits like 0 to 1 and 1 to 0, I'll be using XOR operator. And if you want to invert, you'll be using NOT operator. And if you want to create any mask, I'll be using left shift operator. So I'll be using, in this programming exercise, I'll be using all 5 bitwise operators. How to use, I'll tell you in the programming exercise directly. So now I have one question here. I have totally 4 questions here. So one by one we will discuss how to do that. The first question says like this. I have one variable called as X, and I want to set 16th bit of that variable. So X is an integer variable. So just keep it in mind, integer X. So I'm going to use a variable called as X here, and assigned and initialized with 0. And I want to set the 16th bit of the X variable. So how can I do that? So let us see that directly with a programming example. So all 4 cases I'll show you with a programming exercise. Now you can see here, I'm going to use integer X is equal to 0. And so how to, okay, so how to set the bit? The question you may get, like, how to set the bit. So if you want to set the bit, we have to follow simple logic here. So X is equal to how many bits you want to set and followed by the position. Here you can see I have written here 1 left shift of 16 I have written. So here there are 2 parameters. One is the position, the right side, whatever you're seeing, this is called position. The 16th is a position. It's called mask position, we will call. And the one whatever you are seeing here, this is called mask value. How many bit you need to mask it. So mask value we will call. So we have 2 parameters here. So one is mask value, left side, and the right side we have mask position. So in this example, I need to set only the 16th bit. Set 16th bit data link, right? So if you want to set 16 bit, it's nothing but 1 bit, right? So that's why I'm using a 1 bit mask here. Left side and right side, I'm using a position which is of 16. Very simple it is. I'm going to use left shift operator. So when I use a left shift operator, this is going to set in the 16th position. Bit number 16th will be set like this. So currently whatever you're seeing here, this is how it looks like. When it sets with the 16th position, it looks like this. All bits will be 0 except the 16th bit. Okay. 16 bit will become 1, and when you write it in a hexadecimal value, it looks like this: 0001 and followed by 0040 zeros. This is the hexadecimal value we have to get. Okay, the same thing I'll write it in the code. Now you can see this is my X. I have initialized to 0 here. Now what I'll do, I'll just write one small code here. X is equal to 1 left shift of 16. So this is what I have explained directly in the theory part. Set 16th position. Set 16th bit. Only 16 bit it will set, and I'll be printing the X in a hexadecimal value. You can print it in decimal value also, but it is slightly confusing when you use decimal value. So better whenever you're using a bit level programming or bit level operations, it's better to use hexadecimal value. So when I run the code, now you can see here, I'll just okay, large. Yeah, you can see here. So I'm getting X is equal to 1 followed by 6 zeros, 1 followed by 4 zeros. This is what I'll go for first method. So I'll here actually I'll copy all the things, or one left shift of 17. Now set 16th and 17 bits. So 2 bits I'll be setting, and when I run the code, now you can see in the first time I'm printing 1 followed by 4 zeros. When I create a 2-bit mask, bit number 16 and 17, I'm able to get 3. So this is what even we're expecting here, 3 followed by 4 zeros. Similar to that, whenever you want to set 3 bits, I should get 7 followed by 4 zeros, and whenever I want to set 4 bits, you should get F followed by 4 zeros. So now let us go back to coding here. So now this is for, now I'll go for 18-bit, one left shift of 18, right? So now let us run this code. So now if you see here, so 1 bit I'm setting, 2 bits I'm setting, and 3 bit I'm setting, 7 followed by 4 zeros. Similar to that, if I do for even 19th bit, I'll get F. Now you can see this is 1 bit, this is 2 bit setting, this is 3 bit setting, and this is 4 bit setting. So in this way, we can set the bits using C programming and using bitwise operators. So this is for set operation. I have one more small exercise for clearing the bits as well. So now you can see here I have taken example for clearing. So if you want to clear the bits, so you should, so example I'm considering again X is equal to, I'm considering all bits as 1 1 1 1 1. I'm considering X is equal to F, all F's, nothing but all ones. Now if you want to set, so now I'm going to clear, not set here. So if you want to clear, I have to follow the procedure of this. I need to use AND operator, negation, and setting the bit. The same similar thing, but slight difference. So when you use this, you should get F. So this is the value you're supposed to get when you clear only 1 bit. 1 left shift of 16, negation, and operator. So this is to clear. So this is slightly confusing, but it is very simple. It's not at all much complicated. Just I'm clearing the bits. I'm just negating here, and I'm ANDing, performing bitwise AND operation with existing data. Okay, so this is to clear. Now let us see this, whether will it work or not. I'll go back to coding here. I'll just remove all the things. Okay, so now X is equal to, I supposed to keep now all F's, right? 4F, 5, 6, 7, 8. Yeah, now 6 are done. Now what I'll be doing, so this is what I told. So you have to perform this operation, clear 16-bit. So clear 16-bit. So let us run the code. Now you can see. So X is equal to FFFE FFFF. So how it is getting? So this is getting because of I have cleared 1 bit. 16-bit I have cleared, and I'm getting FFFE followed by 4Fs. So this is for 1 bit clearing. Similar to that, if you want to clear 2 bits, the same procedure we have to follow with a slight difference. Okay, so when you go for 2-bit clearing, you should get FFC 4Fs. You're supposed to get. Now I'll come back to coding. So now I'll be clearing 2 bits here. So if you want to clear 2 bits, same procedure, but I need to add 17 as well here. Clear 16th and 17th bit. Okay, so now let us print what we will get. Okay, I've forgotten to add. Yeah, now you can see here. The first case, whatever you're saying, yeah. So first, just a second. Yeah, so first case what you're getting, that is because of 1 bit I have cleared. In the second case I have cleared 2 bits, that's why I'm getting 3 Fs, C, 4 Fs. Similar to that, if I continue with one more use case, that is 17th is done, right? Now I'll go for 18th, one left shift of 18th, and similar to that I'll go for 19th as well. So in this way you can set and you can clear. So I'll add one more condition here, 19. So let us check the output, what we will get. Now you can see. So this is what I was telling. So this is I have cleared 1 bit, and here I have cleared 2 bits, and here I have cleared 3 bits, and here I have cleared all 4 bits. So that means especially it looks like this: 111 0, then 111 00, and then here it is 1000, and then it's going to be 000, and rest all the things will be remain same as it is. I'm talking about only this part, EC80. Okay, so in this way we can clear it. Okay, I hope you are clear. How to toggle? So I have one more important thing. This is also like, how do you toggle in the C programming? So if toggle means making 0 and 1. So toggle 16 position continuously. Okay, so now we will do that. How to do? For toggling, let us keep it 0. X is equal to, let us keep it 0. Now what I'll do here is I'll be using XOR operation. Okay, I'll be using XOR operation this time. So the cap, whatever you're seeing, this is XOR operation. So now I'll just put one for loop here for int I is equal to 0, I is less than 15. 15 times I just want to toggle it. That's why I have taken some 15 count here. The toggling means making zeros and ones. Now let us run it. What is going to happen? Now you can see here. So first time it is setting 1 followed by 4 zeros. Then the second time it is going to 0. Then again 1 followed by zeros. Then 0. So this is called as toggling. So what do you mean by this? This is going to be like this: 0 0 0 1 followed by all zeros. Okay. So this is, and then 0 0 0 followed by zeros. And then similar to that, 0 0 0 1, then 0 0 0 0, then 0. So in this way 16 position or a 16 bit will toggle. So this can be done using our XOR operation. Okay, so this is a very important question, especially setting and clearing the bits using bitwise operator. Very important question for your interviews, so please concentrate on this. Okay, so I hope this video is clear to all. And if you feel this video is an informative video, please click on like button and subscribe my YouTube channel.